Good morning, all. I am Professor Swamireddy from SR University, Warangal, in Department of Mathematics. Today, we are going to discuss vectors. So, what is vector and what is scalar? On real life, where we used unknowingly, we are using vectors. Unknowingly, we are using vectors. So, before going to vectors, differentiation and integration, first you should know the applications of vectors. Right? First definition of vector, scalar and examples. Next applications of vectors. So what is the definition of vector? A vector is a mathematical quantity. It has both magnitude means size, magnitude or size, and direction, magnitude and direction. For example, velocity. Velocity means example 60 kilometers per hour in the north side or south side. The vehicle is travels 60 kilometers per hour north side or south side, whatever is one direction. Next example is force. 10 newtons force applied in the downwards or upwards, like that. Displacement. Next example is displacement. 3 meters to the right side or 3 meters to the left side, right? Like that, directions and magnitude. This is about vector, right? Next, what is scalar? A scalar is a physical or mathematical quantity, only quantity that has only size, no direction. For example, temperature. So in summer, hot summer, 40 degrees centigrades, right? Or in room, 30 degrees centigrade. It has no direction, just temperature. It is only magnitude. Mass, 5 kgs of mass or 100 kgs of mass. Next example is time, 1 hour or 10 hours, like that. Speed, the speed, 60 kilometers per hour, right? No directions. So now this is about vector and scalar definitions. Now in daily life, when we use vectors, we're going to discuss. The most commonly used examples of vectors in everyday life is velocity. I'm telling address, turn right, turn left, take U-turn, right? Navigation, and next aeroplane, ships or boats navigation, right? These are in daily life, and players also unknowingly using vectors. Just you see one by one application. So some more examples of scalar quantities and vector quantities. Magnitude, but not direct. Distance, speed, mass, energy, density, power, 30 amps power, 20 amps power, length, area, volume, right? Time, temperature, work, right? These are scalar examples. Next, vector, displacement, velocity, weight, acceleration, force, impulse, pressure in the direction of right direction or north side or west side direction, momentum, gravity, and drag. These are vector quantities, both direction and magnitude for this. while talking about the source, you must take direction and magnitude. These are some more examples of scalar quantities and vector quantities. Next is vector. So one more definition or some different types of definitions. A vector is a quantity or phenomenon that has two independent properties, magnitude and direction. Independent. There is no dependency between magnitude and direction. The term also denotes the mathematical or geometrical representation of such quantity. Right? Examples of vectors in nature are velocity, momentum, force, electromagnetic fields, and weight. These are some examples. Right? So, it's the one more definition of vector. Now, some applications. Vector have many real-life applications, including situations involving force, velocity. Consider the force acting on a boat crossing the river. Boat motor generates force on one direction, and the current of the river generates force in another direction. Both forces are vectors. Few applications of vectors now: force, torque, and velocity, and military usage, projectile, gaming theory, design roller coaster, cricket, and volleyball or football, avoiding crosswind. These are all some applications. Now we discuss elaborately one by one. Uh, First of all, force, torque, velocity. If you take calculating every vectorial unit, we need a vector, right? We need a vector. For example, in a moving car, if you take moving car, the tire has mass. It has also initial and final velocity. Initial velocity and final velocity. Acceleration and gravitational reaction. Friction forces due to rotation. And it has torque. Friction forces and due to rotation it has torque. For getting the results, we need a vector. To take the to take the car, moving car, these force, torque, and velocity. These are three at a time produces, right? To take the figure, right? Friction on road and between road and tire, and torque it is rotating, right? And force, right? Like that. Uh, this is the application of vectors. And next is military usage. Suppose if you want to target one point, so how it is reach the target? A cannon is a piece of artillery that uses gunpowder or other usually explosive based on propellants to launch a projectile. Cannon vary in caliber, range, mobility, rate of fire, angle of fire, and fire power. Different forms of cannon combines and balance these attributes in varying degrees depending on their intended use on battlefield. For this, vector must be used, right? If you want to target one enemy's right, point, so we need angle and speed of that, speed or velocity of that, and direction. Right? In military usage, requires these much of vectors. No? different forms of Kiran combine balance these attributes. Right? This is about military usage. And next, vector in gaming theory. Right? We have seen a number of video games. Right? Position and direction and velocities. The position vectors indicate how far the object is. The velocity vector indicate how much time it will take or how much force we should give, and the direction vector indicates in which we should apply the force, in which way we should apply the force. Right? So in gaming theory, if you take, there are many parameters, vector parameters work in gaming theory. Right? And next, projectile. To take basketball or baseball is used unconsciously by the players. In which direction the sportsman throws to that reach that net. Ultimately, they shot the target or throw the ball at a direction which with an angle which is done by the knowledge of vector. In which angle and which speed, what is the speed and which direction. These much of vectors. By practice, the sports person will get perfect. Unknowingly, he is used vectors to reach the target. This is about projectile. Right? In cricket also, if you take any game, cricket, volleyball, football, baseball, right? The player is unknowingly how much speed or how much velocity and what is the angle, right? And what is the direction. They must get by practically. They are not calculating at the time of playing. Simply they practiced and unknowingly used the vectors. Right? Next, roller coaster. Most of the motion in a roller coaster rides is a response to the earth gravitational pull. Right? You see circus or any exhibition. Right? You see this roller coaster. When a train reaches at a peak point, then right to the downhill, it gains enough speed for the gravitational pull. Gravitational pull and how much speed we maintain to apply the gravitational pull, that must important. Otherwise, if the speed is less, the gravitational pull is fails, then it is collapse. So with this speed, it climbs to the next hill. The process occurs over and over until all the train's energy has been lost to friction. The train would be able to keep running as long as no point on the track was higher than the first peak. Right? Here, vectors of forces, acceleration, and velocity, and gravitational forces, right? Important to make safety system. Right? This is important. What is that? Friction, forces, and acceleration, and velocity, right? And gravitational pull. These are all vectors. Some certain speed they should maintain. Then the roller coaster travel very safely. Once it is speed less or automatically the gravitational pull less, then it will collapse. This is very important. At peak point, how much speed required? At down point, how much speed required? Like that, that is formed, right? This is about roller coaster. Next, in cricket, is the most famous game in cricket. In cricket, if a batsman hit a ball shot, there will be three possibilities like catch out or drop before the fielder or maximum, right? Either catch out or stumped out or uh, maximum outside or 4 or 6. It depends on the batsman in which angle he shots and how much the velocity when he hits the ball. If everything fulfill the requirements for maximum force, then the ball goes to over boundaries. Otherwise, the another two incidents can be happen. Right? Goes to the boundaries or catch out or stumped out. These are possibilities. It all about the vectors because of the ball. So the cricketers not measure that vector speed, velocity like that, direction of bat. Just simply they hit the target by practice. It's unknowingly they are using vectors. Okay, this is about cricket. And next example is daily life. Boat crossing a river, right? When a boat crosses a river, there are two velocity work together. What are the two velocity? One is velocity of river and another is velocity of boat. It is two velocities work. The direction of boat change with the respect of the velocity of the river. Right? Opposite directions are different directions. Velocity of river and velocity of river also. So the boatman find a angle for crossing the river to reach the bank of the river straightly. One bank to another bank, he must reach the straightly. He must know the angle and how much speed he maintain, how much speed of the river that will counted, and the angle is theta equal to cos inverse v or velocity by velocity v means velocity of river minus velocity of river vr means divided by velocity of boat. Using this angle, the boat man reaches the one bank to another bank. This is vectors example. Right? And next is crosswind. Crosswind we see in familiar in the terms of crosswind. A crosswind in a wind that has perpendicular the component of the line or direction of the travel. Right? Most of the time we encounter this crosswind. Because of crosswind the flight crashes the earth like that. Most of the planes met with accident because of the crosswind. How? When a plan to land sometimes it faces difficulties for crosswind. The aeroplane speed is one direction and wave direction is another direction. There is a crosswind, right? It faces difficulties for crosswind. A pilot can find out the resultant velocity. So at that time, the pilot must take care to landing of aeroplane and direction with the help of a vector. In which direction he must land and what is the direction? He must know the velocity of or direction of the crosswind also and velocity of the flight and direction of the flight. These are all vectors. Otherwise, the flight unexpectedly the flights met with accidents. This is because of crosswind. Okay. So we discussed many applications of vectors. Now we are going to discuss some fundamental definitions of vectors. Right? Now position vector. So what is position vector? So one object is there. So we have to decide the position of that object. Right? If P x comma y comma b any point in a space, its position vector is given by what is that? R bar. R bar is equal to xi bar plus yj bar plus zk bar. So what is xi bar, yj bar is three dimensions. So if you take this is y-axis and this is x-axis and this is z-axis. Along x direction, the I bar, the vector is along y direction, j bar. Along z direction, k bar. Right? So P is any point, right? P x comma y comma z in three dimension. Moving along the curve AB, if you take the curve AB, right? Let the position of the particle at time t be px comma y comma z. Its position vector is OP. So this is O and this is P. So OP bar, the vectors are denoted by bar. The scalars are simply no bar, right? So R bar is equal to xt bar plus yt j bar zt k bar, which is a function of time, right? The xi bar means x is a function of time, y is a function of time, z is a function of time. If you see the, to take this one, where p is a O, right? Like you take direction of this is R bar. R bar is a position vector along the direction, right? So the position vector signifies the position of the body, right? Or a point with respect to the origin or with respect to the certain point. Here this is origin with respect to the origin or any point. Let I bar, j bar, k bar stand for the unit vectors along the coordinate axis Ox, Oy, Oz respectively. Right? This is the position vector we have to do. And next is unit vector. So unit vector. So what is unit vector? A vector of unit magnitude, the length is 1, used to specify a particular spatial direction. Unit length. Any vector can become a unit vector by dividing it with its magnitude. So if you take R bar is xi bar, yj bar, zk bar, then its magnitude is absolute R bar is equal x square plus y square plus z square. Right? Then unit vector means R bar divide with its magnitude. Divide with its any vector become a unit vector. Divide with its magnitude. Magnitude is given by this. Is a vector of length or magnitude is 1 unit vector definition or vector of unit magnitude used by specific particular spatial direction of this the unit. The length of vector is or magnitude is 1. Any vector become unit vector, already we discussed. V bar is equal, right? This is about unit vector. Next, tangent vector. A tangent vector is a vector that is tangent to the curve, just touches to the curve in a particular direction. So R bar is a parametric smooth curve, R bar T. This is a parametric smooth curve. The tangent vector is given by just this is dr bar by dt. The unit tangent vector is given by unit tangent vector or unit vector is given by caps. T cap is equal dr bar by dt by with its magnitude. Dr bar by magnitude of this dt. The unit vectors are denoted by caps. T cap or P cap is unit vector symbol. Right? The tangent vector is touches the smooth curve at one direction at one point. That is R bar is a position vector. Then its tangent vector is dr bar by dt, right? By absolute of dr bar by dt is about tangent vector. And next, let's take some problems. Find the unit tangent vector at a point t is equal to the curve x is equal to t square plus 2, y is equal to 4t minus 5, z is equal to 2t square minus 6t, where t is any variable, right? Now first you take r bar position vector, right? Then only we define tangent vector. So r bar is equal to xi bar plus yj bar plus z is a position vector. So what is x here? X is equal to t square plus. What is y? 4t minus 5. What is z? 2t square minus 6t. So this is a position vector. Then differentiate t. For tangent vector definition is t cap is equal to dr bar by dt and with its magnitude of dr bar by dt. First write position vector, then differentiate with respect to and take the magnitude of that. That is the tangent vector. Then we will get the tangent vector. Is to dr bar. So dr bar by dt, calculate dr bar by dt. Dr bar by dt is equal to differentiate with respect to t. T square derivative is 2t, right? And 4t derivative with respect to is 4. Here 4t minus 6. 2t square is 4t minus 6. So this is dr bar and with its magnitude absolute dr bar. So square root of 2t square plus 4 I bar common j bar and k bar. So 4t minus 6 whole square and simplify, right? 20t square minus 48t, right, by whole square. So take out 2. So the unit tangent vector t cap is equal to this is the correlation of unit tangent vector. So what we need first, r bar its position vector and differentiation with respect to a time or any variable and with its magnitude divided. Next, this is a one more example. Also, the unit tangent vector at point 2, we decide at point t is equal to, right? Just you put t is equal to and simplify, you will get some particular point. And we can similarly we can calculate x is equal to 3 cos t, y is equal to 3 sin t, 4 t. Find the unit tangent vector. First write position vector. Right? What is the position vector here? R bar is equal to xi bar plus yj bar plus zk bar and substitute x, y, z values and differentiate this. Right? R bar is differentiate dr bar by dt and write the tangent vector t cap is equal dr bar by dt and absolute of dr bar by dt. This is about tangent vector, right? Okay, thank you very much.